job. How much time do I have? 30 or 40? 30 minutes? 40, okay. Hi, thank you for taking your time. My name is Kaz Sato, K-A-Z-S-A-T-O. I'm working at the Google Tokyo office as a developer advocate for Google Cloud platforms. So today I'd like to talk about the machine intelligence we are using at Google Cloud platform. I'm Kaz. I'm a developer advocate for Google Cloud Platform, or we call it GCP. GCP is the cloud platform service just like the Amazon AWS. And I'm focusing on the products like TensorFlow or cloud machine learning or the big data processing tools such as BigQuery. Okay. So, in this session, I'd like to spend some time for introducing what is neural networks and what is deep learning, and how Google has been deploying the technology to our production projects. And also, I'd like to introduce some new products called Cloud Vision API and Speech API that is based on those neural network technology. And also, I'd like to introduce TensorFlow, which is a framework for the machine learning and the deep learning, and cloud machine learning product. So, what is neural networks? Neural network is a function, just like the function you define with the Python or Java. In Java, you don't define a function, you define a method, or a function in the mathematics. So, you can just input your data into the network, then you'll be getting the output. If you want to use neural networks for visual recognition, then you can put images, such as cat images, as an input. Then you would get the output, labels as an output, such as a cat or human face. So it's a function, but the thing is that neural networks can learn from training data sets. So that's the most interesting part of neural network technology. So let's take a look at some demonstration of neural networks, looking at how the neural networks can this classification problem. There are two groups of data points. One is the orange data points, and another is blue data points. If you are a programmer, how do you classify those two kinds of data points? Do you want to write some conditions like an if or switch statements with the thresholds to classify them? So let's take a look at how the neural networks can solve this problem. Here I have a demonstration called playground.tensorflow.org, where anybody can play with the actual neural networks running on your web browser. So by clicking the play button, I can actually running the training of neural networks already in this device. And you are seeing that the computer tries to find the best way to classify the two data sets. Like this. You're seeing that the diagonal line is gradually changing its angle. So this is how neural network is learning from the training data set. Here we have the training data sets in the orange color and blue color, and computer is trying to find the best combination of the parameters to define what would be the best way to classify two data sets. Based on the inputs, like the x1 is the value on the horizontal axis, and x2 is the values of the vertical axis. So, how how the neural networks was able to solve this problem. So we use something called neurons. By neurons, it's the cells inside human brains, and with neural networks, we are trying to mimic the behavior of neurons in human brains. So if you have a single neuron, and if you have two inputs like x1 and x2, then by using the matrix operations, we are trying to mimic the behavior of the human neurons by multiplying the input value with the weight parameters. In this case, we had two inputs, x1 and x2, and we have multiplied the two weights called w1 and w2. And then we check if the output data exceeds the number of the bias. Bias is a threshold. So it's a very simple principle. Looking at all the inputs and the multiplying with the weights and checks whether if the value exceeds a threshold or not. So by using this principle, you can apply the neural networks algorithms to any kind of the data. If you want to do the visual recognition, then you can just convert input pixel data into a vector. It's going to be a very large vector, and do the multiplication with the weights and addition with the biases, and then eventually you get the another output vector which has the probabilities for each levels of the detected objects. If the input has a cat images, then the output vector would have a higher value such as a 0.88 or the label cat. So the thing is that the computer can try to learn what would be the best combination of the parameters such as weights and biases by looking at the training data sets. So programmers don't have to specify any of these weights or biases. All you have to do is just giving many training data sets. That's all. You don't have to write your own algorithms or write your own instructions how to solve the problem. So as you can see in these diagrams, computer tries to increase or decrease weights and biases to minimize the mistakes or errors. So that it's just like the learning, children is learning many things from parents. Parents would be, teaching many times. Every time child makes a mistake, your mother or your father will be, trying to fix that errors. So just like that, computer tries to see the current error rate and try to minimize the errors by increasing or decreasing the weights and biases. So let's take a look at another example. This is a little bit complex problem where we have the two groups, blue and orange groups, with the so-called non-linear classification pattern. So you cannot use just a single line to classify. You have to have much more complex pattern to classify these data sets. So let's see how neural networks can solve the problem. So you saw that. Okay. Now you're seeing that computer tries to looking at the training data set and find how it can classify this shape of the circle pattern. And you notice that we have so-called hidden layer between input data and output data. So that on the hidden layer, we have 5 neurons, and each of single neuron does very simple classification like this. This neuron just checks if whether each data point is in the upper part or the lower part. This neuron checks whether the data point is in the left part or right part. So each neuron is very simple. But still, by combining all the outputs from those neurons, no problem. Okay, thank you so much. No problem. So the last neuron here is combining the outputs from the first neurons, first neuron layer, by multiplying the weights on those outputs, so that the second neuron can compose much more complex pattern from the very simple classification pattern. And if you add more and more neurons, you could have more intelligence on the neural networks. So if you try with 8 neurons, then you will see the shape will be much more sophisticated and much more complex, rather than having less neurons. If you have just 4 neurons, maybe it's really hard for networks to capture the pattern. Maybe you can, in this case, the networks can just form the very simple triangle. But with 8 neurons, it could build much more complex figure, like this. So by using hidden layers and by adding more neurons, that means your networks can have much more intelligence, or that can compose much more complex patterns learning from the training data sets. And the programmer don't have to specify anything about the actual patterns. Computer can find the best patterns from the training data set. So how about this? Let's try another complex problem. This is called double spiral data set. So if you're a programmer and you are asked by your customer or director to classify these data points, what kind of program code you would write? You want to write many if statements or switch statements with the many thresholds and conditions. Maybe you don't want to do that. You don't want to check the X and Y positions of each dot. Instead, maybe I would use machine learning or neural network so that I can let computer find the best pattern to classify these data points, like this. Again, I didn't specify any specific patterns or so-called features to do the classification like this. Computer can find the best patterns based on the training data set. And each neuron does very simple things. These neurons tries to check if the data point is in the central part or the other part. This neuron checks whether the data point is in the upper part or lower part. So just like that. But the end result can be very complex by combining those simple patterns. So by extending this idea, you can let the neural networks recognizing much more complex things, like the handwriting text. By using the very simple neural networks, you can even recognize the handwriting text images. You can convert the image pixel data into a large vector with the tens of thousands of the elements in a vector, then apply it to the neural networks, just like the demonstrations I just shown. And then you would get the output vector like this, and you would have the higher value at the level 8. And computer, by using training data set, computer can come up with the complex parameter sets like this to capture the features of each handwriting text. Now, how about this? How can computer recognize these things as a cat? You have to have more and more hidden layers. So this is a network called Inception model that Google published last year. It has 40 hidden layers in the networks. So that even though it takes so much time and so much computation power to train the model, but you can have the computer recognizing much more complex objects like this. The neurons closer to the input data will be learning very simple patterns like this, horizontal line or vertical line. But the neurons closer to the output data will be learning much more complex objects like eyes and nose or human face. Again, you don't have to specify any patterns or features to computers by yourself. So, this is the neural network or deep learning technologies and how Google has been deploying the technologies to Google services. There are two big challenges for the deep neural network right now. One is the computation power, and another is training data set. So these are the reasons why you guys are not using deep learning yet. Once you have two of them, like computation power and much of a training data set, then you can start applying the neural networks to your own problem, like gaming or ads or the enterprises, anything right now. So these are the problems. So we have started using Google Cloud to solve this problem because we have tens of thousands of machines in Google data center worldwide. And especially we have two unique technologies. One is network technologies and another is container technologies to build the so-called data center as a computer. Means we are building a data center just working as a single parallel computer with the tens of thousands of machines. We have been building our own network hardware from scratch. It's called Jupyter networks. The Jupyter network can hold up to 100,000 ports of 10 gigabit Ethernet. And it has total 1.2 petabit per second right now in Taiwan data center. And it can provide the microsecond latency that can consolidate the computation power of the CPUs and GPU. And also the container technology is very important. Board is our own proprietary container technologies that manages up to 10,000 to 20,000 physical machines in a single cluster. It's similar to Docker container, but the largest difference is the scale. We are managing 10 to 20,000 nodes per cluster and doing the job scheduling and resource management like a CPU resource or memory resource or disk resource with those tens of thousands of machines. So any software engineer in Google can issue a single board command to deploy your own programs to the hundreds or thousands of machines in a few seconds. So that's the reason why we are able to deploy the world's largest deep neural networks applications on our cloud instantly. So, why not applying these Google Cloud technologies to building the large neural networks? So that's the project called Google Brain. Google Brain is the project we have started at 2011 to build an infrastructure for large-scale neural network training. What's the scalability of Google Brain? So here are some numbers of the scalability. For example, we have RankBrain. RankBrain is algorithms used in the Google search service. Maybe many of you are using Google search service every day, but you have been using RankBrain algorithms since last year every day. That is based on deep learning technologies. And we are using over 500 nodes to train the model that can speed up the performance up to 300 times faster. That means you can get the training result in 1 to 300 times shorter than using single nodes for training. For image recognitions, we are using inception model, and by using the 50 GPUs with Google Brain, you can get performance 40 times faster. So those are the reasons why Google can be so successful on applying deep learning technology for our production projects. Now we have many production projects in Google, such as Google Search or Google Photos in Android, or the voice recognition in Android devices, or the optimizing the resource allocation in data centers, or the AlphaGo. DeepMind team just had a match at the Seoul a couple of months ago. They have been using Google Brain for training their neural networks. Now we have over 60 production projects in Google that has been using deep learning technology at Google. And now we have started externalizing this power of Google Brain to external developers. The first product is Google Cloud Vision, and second product is Google Cloud Speech API. Vision API is an image analysis API that has pre-trained model, so you don't have to train your own neural networks. We provide REST API, so you can just send your image file to the API, so that you will be getting the JSON result in a few seconds. No machine learning skill set required to use this API, and it's free of charge up to 1,000 images per month. It has 6 features for detection. Label detection means that you can put any labels on your images, such as cat images or human face or automobile images. Face detection can detect the location of face in an image. OCR, optical character recognition, can convert the text on an image to string. Explicit content detection means that you can check whether the image has the adult or violent images or not. Landmark detection can detect a landmark or popular places. Logo detections can detect the product or corporate logo. Let's take a look at the demonstration. This is a demonstration called Vision Explorer, where we have imported over 80,000 images on Google Cloud Storage and applied Vision API. And by using the result from the Vision API, we did some clustering analysis. So we have the cluster of the 80,000 images here, like sea or sports or vehicle or residential area. So let's take a look at the sports cluster. And you can walk around inside the clusters to look at what kind of images they have. And if you take a close look at each cluster, then you'll be seeing many thumbnails popping up. And by clicking each thumbnails, you can see each images and the result from the API. Like this. At the right-hand side, you can see the labels you are getting from the Vision API. So Vision API thinks this image as an image of sports, player, or football, things like that. And those results are returned in a JSON format like this. But with this demonstration, so you can see it in the UI. So let's go to the cat images. There's a cluster for animals where we have many cats, and also dog clusters are across here too. So if you go to the cat cluster and select this image, then you can see the labels such as cat, and it's not just a cat, it's a cat as a pet. So API can detect that it must be a pet. And also API thinks it must be a British short hair. So these results are all detected by the deep learning algorithms we are using at Google Brain technology. You can also convert the text on image to string by using OCR. Or like this, three candles crossing next. If your image has some faces, then you can find the location of the faces. And also, the API can detect the emotions of each face, whether the face is smiling or is in anger or surprising. If it's an image of the very popular place like stadium, then you can get the name of the place, like API thinks it must be a Citi Field Stadium in New York City with longitude and latitude. And also you can detect the product logo, like Android logo here. This must be a logo Android. So those are the features of the Vision API. And there's another API called Speech API. This is another pre-trained model, so you don't have to have the machine learning skill set to use this API. You can just upload your audio file, audio data to the API, so you'll be getting the result in a few seconds. We support over 80 languages. Streaming in non-streaming means that you can do the real-time recognition or batch recognition. It's in a limited preview status right now, so you have to sign up on the product page to start using the product. But we are planning to launch this product as a public beta in a few weeks. Yeah. Let's show some demonstration. I have some interesting code.
Cloud Speech API allows application developers to use Google's best-in-class speech recognition technology through a simple API. You can send audio data directly to the cloud from your application, and the API will respond with a text transcription of your audio. Cloud Speech API uses the same machine learning technology we use for the advanced voice recognition features on Android devices, such as voice search in the Google app and voice typing in Google Keyboard. What's the weather in Tokyo?
It's 8 degrees and clear in Tokyo.
The API supports over 80 languages and provides high recognition accuracy even in noise environments. We encapsulate sophisticated speech recognition models built on years of Google research with an easy-to-use API for any app developer. So any application can now listen and implement voice interactions with your users using the power of cloud computing. Let's see the Speech API in action by calling it directly from a Raspberry Pi Go robot. The bot can capture audio through its microphone, send it to the cloud, and receive the recognized text in response in real time with partial results returned while the user is speaking. Now, let's see how it works. Can you dance? You can also specify the API what language you would like to recognize. Mare migi. Vire à esquerda. You can combine Speech API with the other Google Cloud APIs. In our bot, we have combined it with Vision API to run OCR on an image of text. Can you read these? Speech API supports both streaming recognition and non-streaming recognition. That means the API is best suited not only for real-time recognition, like I demonstrated, but also for batch recognition use cases, such as transcribing voicemails, podcasts, call center calls, or processing any stored voice data. As you saw, the Speech API lets you add an interactive and voice-activated interface to your application with the power of Google Cloud Platform. Please go to cloud.google.com/speech for more details.
Yeah, that was the video for the demonstrations. And I can show you another real-time demonstration of the API. So this is the web page where you can, actually anyone can try with the API with many languages, but this time I can try with English. Hello, this is a test of the voice recognition by Google Cloud Machine Learning. Yeah. Anyone want to try with the Tango? So you can try it. Can you try it? Can I ask to try this? Please come here and say. Please come here and say any. Thank you so much. So this is the API. So it's really fast. And we provide an API. So anybody can start using this API from any devices. So those are the APIs, and you don't have to. Those are the APIs you can start using right now, and you don't have to have any machine learning expertise or knowledge. But what if you have any specific applications where you want to do image recognition for the very special applications, or if you want to do recognize the for example, if you have a cheater on a gaming server, you want to find any spammers or cheating players in the gaming, or if you want to apply deep learning to the ads technologies, then those API doesn't work for your applications. So instead, we provide a framework called TensorFlow, which is a machine learning framework that lets you build your own neural networks to solve your problem. So we have the machine learning APIs at the right-hand side that requires no ML skill sets. On the left side, we provide TensorFlow and Cloud Machine Learnings. That takes a little bit of machine learning expertise, but you can customize your own neural networks or deep learning algorithms to fit with your application. So what is TensorFlow? TensorFlow is an open source library for machine intelligence, and that has been launched in last November. And actually, it's the second generations of the frameworks we have been using in Google. The first generation is called Display, not Dist. What was that? Not Display. Display is the name of the first generations. And we have migrated to the second generation, which is TensorFlow. And now at Google, any researchers or machine learning engineers are using TensorFlow to build their deep learning or neural networks algorithm. So, for example, the most simple neural networks can be written in a single line of Python code like this, where, I don't know if I can, not sure. Actually, it's not working here. Yeah, this is the line where you define the single layer of neural networks, where if you put a cat image of a cat here as a vector, then you can multiply it with the weights vector, matrix of weights by multiplying and adding the bias vector, and apply the redo or softmax functions to check whether the image must be a cat or not. So this is the most simple neural networks, and you can write it in a single line of Python code. And also, in this line, you are specifying the computer, the TensorFlow, to do the training with the networks you have defined. So in a few years ago, or maybe 5 or 4 years ago, you have to understand the mathematical model or the equation or formulas and write down the C or Python code by yourself to implement all the training or the optimization algorithms by yourself. But now, by using TensorFlow, you don't have to be a math genius to start using deep learning. Actually, I don't have any math background or machine learning background, but still I can start playing with the TensorFlow by using your own training data set and specifying the computer to do the training. And you don't have to understand the details of these things. So this is the power of the TensorFlow. It encompasses the complex part of the neural networks inside the API. So anyone can start playing with the technology. And also we provide some visual tools for debugging the training process. So sometimes it's hard to get the successful result of the trainings. So many researchers or developers are doing many trial and errors trials of the trainings. So it's very important to have a visualization tool looking at the parameters, whether the trainings is going well or not. TensorFlow is portable, so you can start trying out TensorFlow by using your Mac or Windows laptop. So the simple problems like the recognizing handwriting text can be solved by using those laptops. But if you start working with the more serious larger problems such as the recognizing cat face or the finding cheating users in the gaming or ads, then you will find you want to use GPUs rather than CPUs. Because the neural network or deep learning is matrix operations. Matrix operations can be run much faster on GPUs rather than CPUs. By you start using GPUs, you can have the 10 times or maybe 40 times faster performance than CPU. But still, for the serious or production use cases, you have to wait until like at least a few hours or a few days. Or some people are waiting a few weeks to finish your training of neural networks because you have to have many hidden layers, like 10 or 40 layers. Then it takes so long time to train your model. So in that case, you want to upload your TensorFlow model to cloud, where we can provide like 20 or 50 or maybe 100 GPU nodes to you as a rental service. So this portability is the power of the TensorFlow. The other open source based frameworks such as Thean or Caffe or Chainer usually doesn't support the distributed training. So even though you can learn those other frameworks on your laptop, but it's really hard to scaling out the training on the distributed environment. So that's the power of TensorFlow. And after training your neural networks, the parameter sets like weights and biases could be very compact, like hundreds of megabytes. So those parameter sets can be copied onto the mobile devices such as Android or iOS or maybe Raspberry Pi. So even though those devices would not have internet connections, you can have those devices recognizing the images or voice or anything without any internet connection. Another portability of TensorFlow could be provided from our special hardware. We have announced new technology called Tensor Processing Unit. This is a special LSI designed by Google. This is not a CPU nor a GPU. This is a special processing unit just for running TensorFlow or neural networks. And by using this, we are able to get 10 times better performance per watt, performance watt rate. So it consumes 1/10 of the power compared with the GPUs. So, and the result will be the cost and performance for you guys. So you can, in future, maybe in near future, you'll be able to get the TensorFlow learning service that could be much cheaper than using the GPUs. We have been using GPUs for the production projects, including the BigQuery, and actually AlphaGo was using TPUs when they were having the match with DOM. And Google Photos and speech recognition and Street View, those services has been also using TPUs. And now we have launched a new product called Cloud Machine Learning, which is called Cloud ML. It's a fully managed distributed trainings for TensorFlow Graph. So, as I mentioned, there are two large problems right now for deep learning. One is the computation power, and another is training data sets. So if we have a training data set, we can provide a solution for the first problem, the computation power. You don't have to build your own large GPU cluster. It's the hardest part. You can just rent our GPU nodes, like tens or hundreds of GPU nodes, by using Cloud ML service. So by using this service, if your neural networks takes 8 hours to finish training, we can shorten that time, training times, into 30 minutes. It's 15 times faster than running trainings on your single GPU node. So we give the power of the Google Brain to the external developers. So by using your own applications and training datasets, I hope our Google Cloud and its neural network technologies can accelerate solving your business problems. So those are the technologies we are providing right now for neural networks. One is the so-called APIs, ML APIs, where you don't have to understand anything about the machine learning. You can just send your images or audios to the API, and you can get the result in a few seconds. The another product is based on TensorFlow. So by using TensorFlow, you can easily start writing and designing your own networks. And by using the Cloud ML and Google Cloud Brain infrastructure, you can accelerate the adoption of neural network technologies to your own applications. So that's my talk. Thank you so much. So any questions you have?
I have this question first. Can the TPU be replaced completely by TPU? I mean, the other way around. Can CPU be replace the TPU? Is that possible?
So the question is, can TPU completely replace GPU or CPU?
Yes.
Yeah. The answer is currently no. So we have some multiple roadmaps for TPUs, so we'll be continue having more and more new TPUs. So maybe in future it's possible we can replace major part of the CPU or GPU with TPU. But right now we are using TPU only for a certain part. So we're still using CPUs and GPUs too.
The reason I asked this was because I was wondering if somehow these programs or these codes were compiled differently to run TPUs. So it's compatible to run on many platforms, or?
So the question is TPU can be compatible with many platforms?
The exact question is, I think it has to be compiled specifically to the TPU platform.
Your code?
Yeah, if
Yeah.
I want to use the TPU.
No, actually that's the portability of the TensorFlow. So once you have defined your graph with TensorFlow, it can be run on a GPU or GPU or TPU. So you don't have to be aware of any difference of them. So that's the reason why TensorFlow only defines the data flow graph. It's a tool for defining the data flow graph. So that data flow graph can be run on any devices like a TPU, CPU, GPU. Yeah. Any other question?
I think lots of people worry about the evil AI. And I think it's not just the thing of the future because yesterday my friend has just installed Chrome, and there is a feature that Chrome suggests some homepage or site to user, and at that time, the Chrome has suggested the Ilvet. The Ilvet is the site for Korea that has very
It's a good
evil side.
evil side.
I think the worrying about the evil AI is not just the problem for future, but for now. And I'm not sure whether the suggestion was made by AI or people. And I think you should fire the influencer if it was made by people.
I think.
Does Google try to do some worrying about that, and do you have some plan or way to solve the problem?
This is not Google's opinion. This is my personal opinion. But as I explained, the neural network is just a function. It's just a mathematical function. So it's all up to you how you can use it. And by learning the machine learning or neural networks, you can find, so-called AI is still premature to, recognize the humans as the enemies and start attacking them or something like that. It doesn't have any intelligence in it right now. So it's all about how you can use the technology in a safe way. So AI itself, especially in the deep learning, is just a function. You can just input the data and you get the result. Just like that. Okay, I think. Okay.
For just lecturing, because I'm handling the medical information usually. I wonder if I use the calling circuits for training whatever learning or something on the Google network. Is there any possibility to violate the confidentiality or privacy of information? Is it possible or not?
The privacy. Yeah, actually this is one of the frequently asked questions from customers. So all of those services are provided in the Google Cloud Platform, GCP. And GCP has terms and conditions that states we don't look at customer data.
And it is curated after burning training. It is curated from the platform.
Yeah. For example, if the Vision API, if you upload your images or audio data to the APIs, we don't store them, and we don't use those data for training. And for TensorFlow, again, you have to upload your data on our cloud storage, but we don't look at them, and we don't use for our own training. Yeah. So I think those are the questions. Okay. Thank you so much.